This is RD Sharma solution, class 12, chapter 6, Determinants, MCQ, multiple choice questions. If the determinant this is equal to 0, then whether ABC is in HP, that is harmonic progression, geometric progression, arithmetic progression, or ABC are in GP, and one of the expression also, alpha is the root of this expression. So what we'll do here is, see, we'll change the column 1 to column 1 minus column 2. What is the benefit? We have AB 2A alpha plus 3B. Then we have BC 2B alpha plus 3C and 2A alpha plus 3B and 2B alpha plus 3C. And 0. So this column 1 I am changing to column 1 minus column 2. Column 1 minus column 2. What is the benefit here? You will just see A minus B, B minus C. When you subtract here, you get 2A alpha plus 3B minus 2B alpha minus 3C. So 2 alpha minus 2B alpha is, you take 2 alpha common, A minus B. Plus 3 you take you common, B3, B minus C. So you have A minus B also and B minus C also. And 2 alpha A minus B plus 3 B minus C. And what is remaining? BC, 2B alpha plus 3C. And here you get 2A alpha plus 3B and 2B alpha plus 3C and 0. Now if you multiply the first row with 2 alpha, and multiply the second row with 3, and if you subtract it with the third row, then you will get a 0 here, right? So we are changing the row 3 to row 3 minus twice of 2 alpha of R1 minus 3 of R2. So twice alpha, please remember it is not 2R1, it is 2 alpha R1. So A minus B, B minus C is already there. So 2 alpha, let me write it 2 alpha here. And 3B minus C. So 2 alpha and that will be subtracted. So you get a 0 here. Similarly, if you have done this, you have to do it for all of this. So B is multiplying 2 alpha with B, and multiplying 3 with C and subtracting it with 2B alpha and 3C. So what do you get? You again get a 0 here. So BC, so 2B alpha plus 3C minus 2B alpha minus 3C. So get a 0. Okay. Now this is 2A alpha plus 3B, and you get 2B alpha plus 3C. And 0 minus, now this, because you have to subtract it. So you get all of it, the first two element of the third column in negative. So with 2 alpha. So minus 2 alpha, 2A alpha plus 3B plus 2B alpha plus 3C. Okay, let us open it. That is the third row. We are opening it. So only the last element of the third row will be there. And the cofactor will be A minus B, B minus C, BC. Right? So let me just write it here. Minus 2 alpha. Then we have 2A alpha plus 3B. And then we have, I'm taking minus inside. So let it be minus. Minus 3, 2B alpha plus 3C. And this will be, see, let me just show you here. It will be this will be on the next element. So let us solve it. A minus B into C minus B minus C into B. C minus B into C minus B into B minus C. So you get CA minus CB minus B square plus BC. So this BC gets cancelled, you get CA minus B square. So either these are two elements. So either CA minus B square is 0, that is B square equal AC, that is A, B, C are in GP. A, B, C are in GP. What does it mean? B square has to be equal to AC. Or the other element, this element. If you take this, you will get a proper expression, 4A alpha square plus 12B alpha plus 9C. So this can be 0. If omega is a non-real cube root of unity and n is not a multiple of 3, then this determinant, what is the value of this determinant? So non-real cube root of unity. So either you add the 3 rows or either you add the 3 columns. The answer will remain same. So we are adding column 1 and column 2 and column 3. You can do it for row 1, row 2, row 3 also. So 1 plus omega raised n plus omega raised 2n. And similarly here also you will get 1 plus omega n, n. But we know that 1 plus omega square is what? It is equal to 0. But what we are getting here is, in the first row, first column, we are getting 1 plus omega raised n omega 2n. Let us put n equals to 1. It is 1 plus omega square. It is equal to 0. Now put n equals to 2. 1 omega square omega 4. Omega 4 is what? Omega cube and dot omega. So omega cube is 1. So ultimately omega 4 will become omega only. So 1 plus omega square, the same thing will come. So it can be 3 or 3, it can be anything other than 3 multiple. So since question is saying it is not a multiple of 3, the first column will give you 0, 0, 0. So when the column whole is 0, the result will be 0. Now the next one is AR is given, A sub R, that is the subscript. Now we have to find out the sigma. Sigma is addition. R equals 1 to some n, AR. So let me give you an answer here. The correct answer is actually, I'll just show you. It's not minus 2n, it's actually something else. So sigma means it's addition. If you are adding everything, you have to add the internal element also. So one by one you need to know what is sigma. Sigma 1 is what? If you add 1 n times, it will be n. 1 plus 1 plus 1. This is going to be n. If it is n times, it is n. So it is going to be 1. Only the r term and constant term we will add. Other won't change. Because we are doing it for r. What is 1 plus 2 plus till n? It is n plus 1 by 2. Okay, n plus 1 by 2. So sigma r is n plus 1 by 2. What is sigma 2 raise r? R equals 1 to n. 2 raise r is 2 raise 1 plus 2 square plus 2 cube. It goes up to 2 raise n. So the summation we already know. We already done in the previous classes. We have to take s, then 2s will add. So finally 2s minus s will give you 2 raise n plus 2 minus n plus 1 minus 2. So I'm writing directly 2 raise n plus 1 minus 2. Okay. So this I hope you have a bit idea. So I'm just writing it directly. Otherwise you have to go back to geometric progression and then understand this. Okay, so when you have to do sigma 2, that means 2 sigma n, sigma 1 and sigma 1 is n. So that is 2n. So this n won't change, n square won't change, n won't change, n plus 1 by 2 won't change, 2 raise n plus 1 won't change because there is no r there and no constant there. Okay, so sigma n, because the addition is from r equals 1 to n. Since r is not there, it is a constant term, so it will remain as n. Okay. So we are only interested in sigma 1, sigma r, sigma 2 raise r and sigma 2. So these 4 terms, the addition I have already written. Sigma 1 was n, sigma r is n plus 1 by 2, sigma 2 raise r is 2 raise n plus 1 minus 2. The final step is what? Let me just clean it. See, this is the final one. Now we'll do row 1 minus row 2. Or you see, Row 1 minus row 3 is a good idea. Why? Because we have row 1 as n, we have n, in row 3 also we have n. So if we subtract this, row 1 minus row 3, so n minus n is going to be 0, n plus 1 by 2 and n plus 1 by 2, that is going to be 0, and 2 raise n plus 1 minus 2 minus 2 raise n plus 1 will come. So minus 2 raise n plus 1, this gets cancelled, it will be negative 2 here. This is negative 2. Okay. Now 2n, n square, let us keep others like that. Just open it using the first row. So 0, 0, I am not writing it, just minus 2. What will come here is this 2n, n and n plus 1 by 2. Okay. So let us take n from n outside, from first row, second row, or first column, second column. So n square will come out. So what will remain? 2, 1, 1 and plus 1 by 2. So 2 into n plus 1 by 2 minus 1. 2 gets cancelled, n plus 1 minus 1, 1 gets cancelled, you get n. Then you have minus 2n square outside. So it will be minus 2n cube. So as I said, it will be minus 2n cube. The answer is minus 2n cube. This is how it comes. There are various concepts being used here. If a is greater than 0, this is very important because this is going to be used in the answer. Discriminant of ax square plus 2bx plus c is negative. Discriminant is b square minus 4ac. Okay. This is negative. Then this determinant will be what? So what we'll do here is, remember b square minus 4ac is less than 0. And since b is 2b here, so it will be 4b square minus 4ac. That is b square minus ac. B square minus ac is less than 0. Since a is greater than 0 already, so b square minus 4ac will always be 0, less than 0. Now what we'll do here is, see, a is there, ab and bc. And in the third row, we have ax plus b. So what we'll do here is, we'll multiply the first row with x, second row with nothing, and then we subtract. So a into first row with x, second row with nothing. So we have to do r3 minus x into r1 minus r2. Right? So this second one also like this only. bx plus c minus bx minus c. And since we have a 0 here, everything in the last element, two elements of the last column will come as negative, because it will be 0 minus ax plus b minus bx plus c. So I'm just writing like this, minus ax plus b plus bx plus c. Let us open it using the third row. When we open it using the third row, what do you get? The first two elements I am not going to write because they will eventually be 0. So third we are going to write. It will be minus ax plus b plus bx plus c. So it will be simply ax plus bx plus b plus c you can write. So ax plus bx plus b plus c. And then we have ac minus b square. Okay. I just told you AC, b square minus AC is always less than 0. Okay. And since b square minus AC, and we have already seen that b square minus AC is less than 0, and since A is greater than 0. And we have a negative sign also. So whatever happens, the result will always be negative. I hope you got the idea. This AC minus B square was there. We took the negative inside. B square minus 4 is AC. B square minus AC is always less than 0, as we discussed earlier, since A is greater than 0. So this whole concept, this whole expression will always be less than 0. Since AX square plus this AX square plus 2BX plus C will always be positive. B square minus AC always be negative. So the whole result will always be negative. I hope you got the idea. You need to just understand those concept of the linear equation and the quadratic equation. Quadratic equation, we know how to do that. B square minus 4ac is less than 0. That is why we are saying it to be 0, because a square plus 2bx plus c is discriminant of this is negative. That is why we took it. And a square plus 2bx plus c is not going to be 0. That is why it is 0. Negative, sorry. The value of this. So this kind of question we have already done. So what we'll do here is, from the first row or the column, it is up to you. I am taking 5 square from the first row, 5 cube from the second row, and 5 raised 4 from the third row. So what all is remaining? This is 1, and this is going to be 5, this is going to be 5 square. So 1, 5 and 5 square. From second row we are taking 5 raised 3. So 1, 5 and 5 square will come. Then the third row we are taking again 5 to the power 4 common. So you get 1, 5 and 5 raised 2. Now you see, for a determinant to be 0, we need 2 rows or 2 columns to be same. Here we have 3 rows as same. So it is obviously going to be 0. Determinant, but you know the property, determinant is going to be 0. Now in this question, each and every element, you can say, how to write that. Main is this. Log 3, base 3 is 5 and 2. So 5 and 2 is 2 raised 9. So you can write it as log base 3. This is 2 raised 9. So 9 goes in front, log base 3, 2. This is the first one. All of them you have to do. I'll show you one more of it. Log 4, 3. Now log 4, 3, 4 can be written as 2 square. This is 2 square, 3. Now 2 square when it come outside, it will be half. So log 2, 3. So first one I showed you the log 3, 8 now. Second also we saw. Log 3, 8 is log 3, 8 can be written as 2 cube. So 3 comes in front, 3 log base 3, 2. I hope you, how did it come? You got the idea? Now log base 4, 3. Log this 4 can be written as 2 square, 3 raised 9 can be written as 3 square. So half will come from 2 square, 2 will come from 3 square. So half and 2 this gets cancelled, log base 2, 3. Now all of this, log 2, 3, log 8, 3. So this also you can write. Let me show you here also, log 8, 3. 8 can be written as log 2 cube 3. So 1 by 3 will come outside. 1 by 3 log base 2, 3. And then we have log base 3, 4. So log base 3, 4. This 4 can be written as 2 square. This comes in front. 2 log 3, 2. Okay. So all of this we are going to take one by one. Log 3, 4 is log base 3, 2 square. 2 will come outside, it will be log 3, 2. So each and every element you have to use the property of log and write. Now I'm just clearing it now. Let us take things common. From this log 3, 2, log base 3, 2, whenever I'm saying log 3, 2, base is there, log 3, 2. And log 2, 3 you can take outside. But you know log 3, 2 and log 2, 3, they are inversion of one another. So you can just cancel it out. Right? If you take a common base, it will log 2 by log 3, log 3 by log 2, it can be cancelled. What is remaining? 9, 3 minus 9, 3, half and 1. This is what is remaining. From the second matrix or determinant, first let us do this one. 9 minus 3 by 2, it is going to be 9 to 18 minus 3 by 2, it is 15 by 2. Now here, you can take log 3, 2 and log 2, 3 common. And this also says log 3 by log 2, log 2 by log 3. Log, if you take a common base, it can get cancelled. So it is going to get cancelled. 1 by 3, 2 will come. So 2 minus 2 by 3. So it is going to be 6 minus 2 by 3. So it is 4 by 3. So 15 by 2, the log all got cancelled. log 3 2, log 2 3. In both the cases it gets cancelled. Here also, so you can just cancel those in front of these numerals, and finally what do you get? 15 by 2 and 4 by 3. So 15 by 2 and 4 by 3, let us write it. 15 by 2, 4 by 3, and 2 gets 2, 15, 2 is 30, 30 by 3 is 10. So answer is 10 here. This question we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.